Hey guys, so reactions of alkane. So we're done with nomenclature. Well, not exactly. We will do more nomenclature on what we call reaction functional group, whatever they usually call it. But yeah, functional group derived from reaction of other functional groups. Okay, well, can't wait for that to happen, isn't it? Well, today we're going to look at, I guess, the simplest reaction. So we'll start with the simplest reaction. Then, of course, as time goes on, it gets a little bit more and a little bit more complicated. So let's start with the simplest stuff. This won't take long. This, of course, is the reaction of alkanes. Now, there's two reactions for alkane. So, number one, we have combustion of alkane. Now, this is not something you haven't seen before. Okay? For example, CH4 is a simple alkane. So when you're combusting CH4, what are you combusting it with? In other words, what are you reacting it with? Well, hopefully you know, is oxygen gas. Okay? Now, this reaction will go to completion as long as oxygen gas is available. And of course, your products is going to be carbon dioxide and water. Okay, so that's combustion. So looking at, of course, other alkane, like octane, reacting this with oxygen gas will give you the same thing. Now, what you need to do, which is still very important, is the balancing of these reactions. So make sure when you have time, you go through the balancing of these reactions. Now, in terms of combustion, these are known to be complete, if you remember. Okay? Which means there are times when these reactions are incomplete. Now, when are they incomplete? Let's refresh your memory. When oxygen gas, of course, is, I guess you can say not enough. Okay? Not enough or scarce to react with the methane that you got over there. Now, when that happens, you're going to get carbon dioxide, you're going to get water, but unfortunately, you're going to get some of these elemental carbon, usually in the form of ash, and this dangerous carbon monoxide. Now, this is incomplete. Incomplete combustion is not balanceable. So don't even bother balancing these things, because you don't know exactly how much not enough this is going to be, if that makes any sense. All right, so that's combustion. That's something we know a long time, brings you right back to those great memories in grade 10. So let's take a look at what we should know here now in grade 12. Let's take a look at this reaction. Okay? This reaction is known as substitution. Okay? Substitution. So, in terms of alkane, what are you substituting? Well, let's take a look at this example. Let's go back to structural formula, because that's easy to work with. Here's a structural formula. Okay, this is an ordinary alkane. Methane. Now, if you react methane with some sort of, I don't know, halogen, like chlorine gas, okay? Now, there's a restriction here, meaning that this reaction will only occur if there is a fair amount of heat, which we will represent with a triangle, and under the power of UV. So ultraviolet rays has to be there. So some heat, some ultraviolet rays. Now, what happened is this. So let's take a look at the reaction itself. Okay. Now, there's 3 parts to every reaction, which we will talk about probably way later in a later date, probably in a couple of weeks. Okay? But what I want you to know right now is that H and Cl will switch spot. Okay? As a result, what you're going to get here is this. Okay? So you get a alkyl halide. Okay, that's what CH3Cl is. This is an example of an alkyl halide because we all know that these are alkyl group, and this is coming from a halogen. So we call this an alkyl halide plus, okay, some sort of acid. Now, it might not be an acid. It could be a gas, but it's going to be hydrogen, I don't know, some sort of halogen. Okay? So it might not always be an acid. Remember, in order to qualify as an acid, it has to be in an aqueous form. Nobody said that HCl right here is in aqueous form. It could be a gas, so it could be just hydrogen chloride, but let's just call it an acid for now. I hope you get the idea. Okay? So, that's what we know as, of course, substitution. So let's do another example. Okay, we have ethane. Okay, reacting, of course, with fluorine gas under the influence of UV and some heat. Okay, one of these H's will switch place with one of the F. So what you're going to get, of course, is CH3CH2F plus HF. All right. Hope you guys are still following suit. Still okay. So another ethane, and let's do a bromine gas. Okay, so under UV, under some heat, you get this plus HBr. Okay, so that's substitution. So hopefully you understand that substitution. What's substituting? Of course, what's substituting is the H with one of the halogens. That's what's substituting. So you can think of it like these two guys got together to form HCl. Of course, this guy is now missing a bond. This guy's missing a bond, so they bond with each other, kind of thing. You can think of it that way. Now, it's not complicated, is it? Can it be complicated? Of course, it's organic chemistry. Of course it can get complicated. Check this guy out. Let me do structural formula. What I have here is propane. Oh, I used lots of propane this weekend in a farm barbecue. Or last weekend. I'm going to use more this weekend. I'm going to react this with fluorine gas. Okay? Again, I'm going to have some heat. I'm going to have some UV. I guess what these guys are acting as are catalysts. Okay? Even though it's not really just a catalyst, but a requirement for these two to react. But still, okay? They're catalysts. You can treat them like catalysts. Now, question. What are your products? Now, one thing's for sure. You're going to get HF. That's for sure. Okay? But what else are you going to get? Well, if what you said earlier was true, that HF gets together, of course, to form this. It only makes sense that you get this. Right? Now, just to give you the name, this is 1-fluoropropane. Propane. Yes, that looked like an A. Okay, this is 1-fluoropropane. Now, this is the tricky part about organic chemistry. Is it always this that is substituting? Can it be this? Can it be this? You know what? Certainly. Nobody said that this H has to be the one that gets substituted. Nobody says that. Okay? But the question is, this, or this, it really don't matter. This and this and this don't matter neither. Because when you do the substitution, you'll always going to get 1-fluoropropane, except these two. Check this out. Let me use another color here. Okay, I'm going to do this reaction again. But this time, my attack is this H and this F. Okay, so under the influence of ultraviolet rays and heat, oh yeah, you're going to get hydrogen fluoride. But what else are you going to get? Let's draw this. This is what you're going to get. Now, if you were to name this, you'll notice that, oh, this is not 1-fluoropropane. This is actually 2-fluoropropane. 1-fluoropropane and 2-fluoropropane is not the same thing. They are isomers of each other. Oh yeah, they are. But they're not the same thing. They most likely have different chemical properties. So, in terms of organic reactions, you can have multiple products. Okay? The reaction itself can attack anything as long as it makes sense, and to determine the various product that it's going to make, it's very important that you can name them. Because once you name them and they have different name, oh yeah, they have different products that can be made. Okay? So it's not as simple as this H is the one that is always going to be substituted. No. Any of these H can be substituted. Okay? And for an example like propane, there's two hotspots. These or these. Okay? As the hydrocarbon gets longer and bigger, you're just going to have more and more products. No doubt. Okay? Now, if you decided to study organic chemistry in the post-secondary level, you'll notice one more thing though, that this and this are not going to be equal. Meaning that if you're going to take propane and you're going to react it with fluorine gas, okay, if you're going to take these two things and you're going to react it in a reaction vessel, it's not like you're going to get 50% of this and 50% of that. That's not going to happen. Okay? I can tell you right now, you're going to get more of these than this. Okay? This, you'll get more. Now, the reason I'm not going to tell you right now, you'll know later on. Okay? It has something to do with nucleophile and electrophile, which I kind of will get to later on. Okay? But in the meantime, if I were to give you a question on a test, propane reacted with fluorine gas, I want to see hydrogen fluoride. I want to see 1-fluoropropane. And I want to see 2-fluoropropane. How does that sound? All right, so I have a question for you. I want you to do this for homework. Let's clear the screen. Okay. I'm gonna give you this. Yeah, you know, I'll give it to you in structural formula. Even though, and you know, I don't like structural formula. Okay. Reacting with chlorine gas under the influence of UV and heat. I want you to tell me the products. Okay. How many products am I going to get? Well, locate all the products. Okay? So that will be your homework for today. Just to see that you guys understand substitution. All right? Bye now.